In the mine geology data management area, a lot of organisations have solutions in place, but they don't have great integration with their mine planning tools, and also they tend to not manage their spatial information as well. With our solution, Maximum Return, it covers the full open pit blockout process. It manages all the spatial data, and it tracks all your logging, your sampling and your assay results, so that geologists are able to use that information to get a better understanding of material behaviour and grade, etc., as it hits the plant and is mined and moves through the process. The important point is that mine geology is the first step in the process, and usually they're quite often understaffed and overworked in a sense, so that they perhaps don't have the time to spend that they'd like to, understanding the geology, etc. And by having the right kind of data management solution in place, it helps drive those efficiencies so that people can spend their time, on the important things, which is understanding the geology.
So I might just chip in there, Mark, and add, as a senior mine geologist or an operational superintendent on the site, it's your responsibility to make sure that the mining guys know exactly where every rock needs to end up in the mine. And that's the role of the geology function, to demarcate different material types and tell the mining guys that rock has to go to the mill, that's got to go to this dump. Sometimes, because of the production pressure, the samples that feed into the process don't come back in time, or it's just in time. I've seen lots of examples where blasts have been initiated without a full set of information supporting the decision about where these rocks go. That's a disastrous situation. That's going to cost you money when that happens. So as the senior mine geologist or superintendent, it's their responsibility to make sure they've got the information at the right time, and they produce the blockouts that we'll talk about in a minute, so the mining guys know what to do. So it's super critical. The key thing for this solution for me is that it provides not only the management and the integration, but the review of quality and quality control of the samples and the process, because that's where you make or lose money.
And I think the other thing there is it's not just about understanding the grade. One of the big things our customers have said to us is understanding the nature of the materials, because obviously it's important from a handleability perspective moving forward.
So what we've seen in the industry for the last 20, 30 years is that the geologist on the mine will customise their general mine planning package, like a data mine or a Vulcan. They'll write custom scripts to create a workflow that does what they want it to do. So that's fine. There's been a lot of smart people do some great work doing that. But when they go, which they will, because that's the nature of mining, people come and go. People who come in may not be able to understand that, and if it breaks, they won't know how to fix it. Having an inbuilt systems has that inherent flaw in it. And it's a complex process. The mine geology process is, whether it's blast hole sampling or RC drilling and sampling, that's where it starts. You've got to get the samples, you've got to get them through a laboratory, you've got to get information back from the laboratory, you've got to quality check it, you've got to get it into a system where you can look at that data in conjunction with other data and geological models and integrate all that information, then decide what the demarcation is going to be, and then feed that back to the planning system so the guys know what is in front of them in terms of what they're going to mine. So it's actually a really complex process that happens very fast, typically, and within a custom in-house built system, it's quite fragile.
And I think picking up on that point, it's also a point Heath made earlier, it's about exposing the data. Quite often if it's in a general mine planning tool, unless it's really locked into the users of those tools, that type of data, whereas Maximum Return's built on SQL Server, it's accessible by anybody in the organisation. So quite often organisations want to do things like scheduling and use that information as part of that process and further down the demand chain, as it were. Yeah, I think one of our real strengths from a mine geology data management perspective is Maximum Return is not a solution in isolation. We have an automated ore blocking tool that integrates into Maximum Return, and we're also working later this year to integrate Model Manager, our block model management tool, into Maximum Return as well. So it's having that complete suite of products that address the mine geology world, as it were, and I think that's quite a unique strength.
I'd add to that, Mark, and I think customers come to us because we've got expertise. To blow our own trumpet for a bit, I've been in the game 30 years, mostly in mining, a bit of consulting. Mark and I first came across each other in 2006, where Mark was building a web-based mine geology system for me in one of the big miners. So there's, we're talking about 15, 20, 30 years experience here in K2 Fly with these sorts of processes and understanding how they work and how they can go wrong. This is a key theme through all our solutions, and that is that we're agnostic to platform. We're agnostic to general mine planning packages. We don't care. We just want to integrate and give people web-based solutions that work seamlessly with their workflows.
I think obviously the cloud is very important. There's a mass migration to the cloud in the big miners. But I think more and more automation, especially in the space, and we'll cover this when we talk about our ore blocker product. So what miners are trying to do is currently their short-term schedules are typically 2 weeks long, and they're trying to stretch that out so that they've got more visibility of what is occurring ahead in the mining process. But of course that means now you have to do more and more blockouts, which is very difficult from a manual perspective, and there's a requirement then to automate that process.
Yeah, absolutely. We have seen a trend from doing blast hole sampling to support the mine geology process towards drilling well ahead of production so that you get more confidence over a longer period of time in front of where you're mining. And that's driven by the fact that it's really hard to get a good quality sample from a blast hole. But it's also the understanding that if you drill ahead, get the high confidence information, close space information well ahead for a whole bench, then you see the geology much better and you can optimise the blasting process. You can put the blasts in the right place to minimise ore loss and dilution. So people are now understanding the value of doing that and moving in that direction.